Welcome back. Today I'm going to go over the next part's answers. Again, hopefully you've checked the answer key. Hopefully you've tried these first and are just getting some ideas of how to fix some mistakes that maybe you made instead of trying to learn through these, because I'm going to go through them a little quick. So here we go. For factoring, I'm going to do the factoring by grouping method. I'm going to also be thinking about greatest common factors and looking to see how we factor these completely. So for number 10, my first thought is I see a 6 as our leading coefficient attached to the front, and I think if I can take a 6 out of everything, that's going to make my life easier. And what do you know? 6, 42, and 72 are all divisible by 6. So I'm going to factor out the GCF, which is 6. And it's going to leave us with x squared minus 7x plus 12. Now for factoring, let's see. I'm going to ignore this 6. The GCF we don't really have to think about. Just make sure that it's attached at the end. A times C I'm going to throw up there. 1 times 12, that is 12. Our B value is negative 7. So we are looking for two numbers that multiply to 12, add to negative 7. Since they add to something negative and multiply to something positive, they're both negative. And what two numbers that multiply to 12 make me think 7? That would be 3 and 4. So our two values are negative 3, negative 4. Now what we're going to do is we're going to take x squared minus 7x plus 12. X squared is going to look the same. The plus 12 at the end is going to look the same. But we're going to take minus 7x and rewrite it as minus 3x minus 4x. Now we're going to do some factoring by grouping. Looking at the first group, we can take an x out. That's x squared. Oops, sorry. That's x times x minus 3. Looking at the second group, we want to factor out something, so we have x minus 3 left. That negative right there at the front, we have to take out a negative 4. Don't forget that sign. And if you see our matching pieces, when we factor, not forgetting about our GCF of 6, our final answer is 6 times our matching thing, x minus 3, times whatever's left over, our x minus 4. The next one, no GCF here. 3 doesn't go into 19. In fact, 19 is a prime number, so looks like we have to do everything as is. On the top, we're going to do 3 times 20, which is 60. I'm going to put 19 down here. We're looking for two numbers that multiply to 60, add to 19. This could take a little bit of thinking. Maybe you got that table. Maybe you just use your calculator and start trying to divide numbers. It ends up being 4 and 15. 4 times 15 is 60. 4 plus 15 is 19. So we're going to take 3x squared plus 19x plus 20 and rewrite as 3x squared plus 4x plus 15x plus 20. Looking at the first group, 3 and 4, can't divide anything nice out of that, but we can take an x out. That leaves us with 3x plus 4. Now again, when we look at the second group, we want to factor something out so that we have 3x plus 4 left over. That is our goal. We can't, it's not factorable, but it tells us to factor, so we should assume that it is. Both of these are divisible by 5. 15 divided by 5 is 3, 20 divided by 5 is 4. So we're going to have that plus 5 that we're factoring out, taking out our matching sections. 3x plus 4, our leftovers x plus 5. There is our factored form. 3x plus 4 times x plus 5. Number 11. I would love to say that this one is easy, but this one definitely is a little tricky. First thing I want to think about is there is a GCF. You can take a 7. You can factor out a 7 out of each 7 times x squared minus 1. Now, here you might say I'm done, but unfortunately, this is the difference of squares. Now, you might remember how to do a difference of squares automatically. If you don't, here's what I want you thinking about. Our a is 1, our b is 0, our c is negative 1, so we're looking for two numbers that multiply to negative 1 and add to 0. Those two numbers are 1 and minus 1. Now you want to do the long way, we can do that. X squared plus 1x minus 1x minus 1. I want to do that in black, I'm sorry. Looking at our groups, we can take an x out. 1. We got to factor something else, so we get x plus 1, and then we're going to factor out a minus 1 to give us our final answer of 7 times x plus 1 minus 1. Difference of squares. Make that one a little bit faster if you remember how to do that. For this last one, I'm going to do it just a little bit quicker. GCF, first of all, is 4y. Leaves us with y squared minus 4y plus 4. Thinking about a times c, that's 4. Our b value is minus 4. What two numbers multiply to 4 and add to negative 4? That's negative 2 and negative 2. Now I'm going to do the shortcut for this one. Our leading coefficient on the y squared is 1 now that we've taken out the GCF. So when this leading coefficient in front of the y squared is 1, we get to automatically jump to our factored form from our two numbers that we see in our x. Don't forget about your GCF that we took out. Now, you can leave your answer like this. You might also see the answer like this. 4y times the quantity y minus 2 squared, because we're multiplying by it twice. That answer looks a little bit nicer than the other one. Besides, they are the same. Finally, Chapter 9, Part 1 stuff. Zero product property. Here for the first one. It's already factored for us. And when we have factored form and it's set equal to 0, all we have to do to solve is take the factors and set them equal to 0. So if x plus 2 equals 0, to get x by itself, we get x equals negative 2. And over here, when x minus 4 equals 0, we add 4 both sides. This with our second answer, x equals 4. Now number 15, very similar, but we got to solve by factoring. So when we're solving, we're still looking for x values that make the equation true. But we're going to do that by factoring. Factoring is not the end, though. We're going to help it out by factoring. So, two numbers that multiply to negative 8 and negative 2 happen to be negative 4 and 2. I'm going to, again, use that shortcut I was talking about before. So that's x minus 4 times x plus 2 equals 0. And if you notice, this is the exact same factored form as number 14. So hopefully you don't mind. I'm going to skip right to the answers. X equals 4 and x equals negative 2. Graph a quadratic function whose solutions are x equals negative 2 and x equals 4. Solutions, the word I want you thinking about when we're talking about a graph and the word solutions is x-intercepts. I guess that's a phrase. Forgive me. So the x-intercepts on the x-axis need to be at negative 2 and 4. From here, you can graph any kind of parabola-looking thing that you like. You want to make it a little bit more specific. The axis of symmetry is going to go right down the middle. So, maybe you're drawing something here, down here. And then, give it your best sketch. That looks okay, I guess. There's a parabola with x-intercepts, aka solutions, at negative 2 and 4. Finally, what are the solutions from the table? Again, if we're thinking solutions are x-intercepts, what do we know about x-intercepts? Even from this problem right here, those were the points 2, -2, 0, and 4, 0. The y coordinate, not intercept, the y coordinate is 0 for solutions. So in our table, I'm going to put boxes around the places where the y coordinates are 0, so our solutions are x equals -3 and x equals 1. Hopefully that was helpful. If you made some mistakes, you see your mistakes. Factoring is definitely tricky, but hopefully that helped you out. And again, good luck with the rest of this. Next video will be posted tomorrow.